Welcome back. In the last class, we covered the basics of PN junction diode as well as GNA diode, like what is the equivalent circuit with respect to the biasing of the PN junction diode as well as GNA diode. Okay. Now let's see, before seeing clippers, let me cover clampers, then we'll go to clippers. Okay. Now write down clampers. Okay, now let me cover, there are many clamping circuits, but typical clamping circuits are 6. Wherever PN junction diode capacitor is there, they are there, then you can think that it is doing some clamping action. The voltage will be more, or I can say whatever input peak to peak you have, your output peak to peak will be same, but the average value of your output signal will be changed if there is a capacitor and PN junction diode. Okay, that is what people call as voltage doubler, tripler, or change, those things. Okay, to what level you are trying to clamp your input signal, that is what is your clamper. You can call this as level shifter. What is that? Let us say I am applying my input signal at the input, then I want to change the level of this. Let us say the level, let's represent with respect average of your input signal. Then actually every value of your input signal will be changed to higher voltage or lower voltage, right? But just to represent, let us take the average value, right? Then if the average value of your input signal is taking or is going high, then are going low, therefore it is clamping to a different level. That is what is called a clamper or level shifter. The level of your input signal is, or the average of your input signal is leveled to a different voltage. Okay. Now let's see how to get it without changing the shape of your input signal. Your input signal shape should not be changed at the output. Okay. But clipper is different. A clipper is nothing but your input signal shape won't be preserved at the output. It will do some clipping. Clipping means if there is a voltage which is more than 1 volt, clip it. Therefore it is going to chop your input signal, and that is what is going to be passed to the output. Therefore the signal shape is not preserved at the output when you compare with respect to your clamper. Clamper is nothing but whatever input peak to peak you have, the same is expected at the output, but the level or the average of the signal is shifted to a required value, whatever you want. Okay. Now there are 6 typical clamping circuits. Out of that, let me take, this is what is the first one, then we will see remaining 5, but out of 6 I'll explain only 2, remaining 4 are homework for you, but I'll give you the procedure. Okay. Now this is what is your capacitor. If capacitor is in series to your input output, and there is a resistor, and there is a PN junction diode. And this is what is our output, and this is your input. Okay, and this is C, this is R, and this is what your diode D. Okay, this is what your first circuit. Okay, now let me apply a square wave. Let me apply a square wave. This is what your time t, and this is what your input voltage, and this is what is your time period t. Okay, this is what your time t is equal to 0. Let us say this is what is having 20 volt and minus 20 volt. Then tell me what is your input peak to peak? Your input peak to peak, right? What is that value? That is 40 volt peak to peak. Or you can give 10 volt plus minus 10 volt, anything. I am just taking one example. Therefore it is 20 volt and then minus 20 volt and the time period. Here the assumption is, if you don't want to see the change in the shape of your input signal at the output, only if you want to see the level of your input signal to be changed at the output, right? Tell me in this example, what is your average value of your input signal? Plus 20 minus 20, average is 0. Therefore the average, the 0 average value at the input will be clamped to a different value. That is what, whatever you want, you'll get it. Okay, but in this circuit this is fixed, but if we want to change the level, that we can change by introducing a battery here or whatever it may be. Okay, either positive direction or negative direction, that depends on you change the direction of your PN junction diode, then it will go to positive clamping or negative clamping, etc. We will see those things. Now, if you don't want to see any change in the shape means when I say this is a square wave, I am expecting square wave, because if there is a capacitor and resistor, whatever it may be, the exponentially charging, discharging, and the shape of your output signal, the square wave will be changed. To do not see that effect, the condition is the time constant R into C, the time constant should be very much greater than the time T by 2 RT, that is very much greater than time T or T by 2. Anything is fine. Therefore, within this half cycle, right, your capacitor, if there is RC combination, your capacitor will not charge. The meaning of that is the capacitor will not charge or your capacitor will not discharge. Okay. Now, for this we want to find what is V naught. Okay. The condition is the time constant. If RC is coming to picture, the time constant RC is very much greater than the time T or T by 2. Now, let's see what is your output. Okay. Whatever maybe there is a blind procedure, you try to follow the blind procedure. Okay, what is the procedure? The procedure is, this is the procedure for all clamping circuits. If you follow this procedure, no need to do multi-cycle analysis. If you don't follow this procedure and then if you just start, then you may need to do like first cycle, half cycle, next half cycle, next half cycle, next half cycle, we need to continue. Then ultimately you'll get the steady state output voltage for multiple cycles. But if you follow this procedure for one cycle itself, for the first half cycle and the negative half cycle, you'll get the answer. Okay, the procedure is number 1, apply the input for which diode is on, and I want to tell one more point. See, in this case, what does that mean? What does it mean? Apply the input for which diode is on. 20 minus 20. For what voltage your diode will be on? Plus 20. Therefore, you need to start with plus 20. When you start with plus 20, something will happen. That's what we will see. Remember here square wave, it has only 2 levels, plus 20, minus 20. If you know what's happening to plus 20, minus 20, then you can say going up, going down, that we will see. But if you take a sine wave, trapezoidal waveform, a ramp signal, or I can say a triangular waveform, any signal having maximum value, minimum value, or positive peak, negative peak, right? Just deal with peaks. If you know what's happening to the peaks, right, then same thing can be expected for all the voltages what you have at the input. For that, no need to deal for all different values of your input. Just deal with peaks. When I say a triangular waveform, plus 20, minus 20, deal with plus 20, minus 20. What's happening to plus 20, minus 20? Let us say both are shifting up, then complete waveform will be shifted up. No need to do what is intermediate voltage, what's happening and all, nothing. Okay, that is what it is. Therefore, apply the input. When I say input, the peak value. Okay, apply the input for which diode is on. Similarly, sine wave also, maximum value and then minimum value. You just try to observe only for these two, then remaining things will be automatically shifted up to the level with respect to like your other, with respect to your peaks also. Now, the second one, apply the input for which diode is on, done. Next, when the diode is on, find the voltage across the capacitor. Find the voltage across the capacitor. Voltage across the capacitor. Let me call that as VC. Therefore, now that's what we will apply this. When diode is on, then it is short circuit. You take it as ideal diode. When this is what is short circuit in parallel to a resistor, short circuit only. Therefore, now R is not coming to picture. Then what about your effective R? Your effective R, because of PN junction diode, which is in forward bias, will be 0. Let us take ideal case. Then 0, then time constant of the circuit will be 0. Your capacitor will charge quickly to the input what you have. Therefore, what will be your voltage across the capacitor? Whatever input you apply. Therefore, that is what? Find the voltage across the capacitor Vc. Now, the last step or the third step, for the other phase of the input, because we have two phases, right? Like two phases in the sense positive peak, negative peak. Okay. For the other phase of the input, for the other phase of the input, what is your output voltage? Then, here find the voltage across the capacitor, and which is nothing but what? This is nothing but Vc, and output voltage V0, and output V0. Because ultimately we want V0, right? Therefore, for the first half cycle, V0, you know already. For the second half cycle, what is V0? Your V0 is not simply what? Vi, it will be sum of your input voltage and already the capacitor which is already charged. Va and then Vc. We will see that. Sometimes it will be subtracted, it will be added, that depends on the output voltage to be shifted up or shifted down. Okay. Let's see, let's follow. Only 3 points we need to follow. Okay. Therefore, what is the first one? Apply the input for which diode is on. Whether you need to apply, we need to start with either positive peak or negative peak. That decides, that will be decided by whether diode is conducting or not. Therefore, apply the input for which diode is on. Next, once diode is on, your capacitor will be charged to your input. Find the voltage across the capacitor, and once you know voltage across the capacitor, and similarly you find what is V0. Third one, for the other phase of the input, your V0 will be sum of your Vi and voltage across the capacitor which is already charged. Okay, let's apply this and then let's see. Okay, now first point. What is the first point? Apply the input for which diode is on. Therefore, first point, apply the input for which diode is on. Tell me for what input your diode will be on? For plus 20, right? Therefore, when Vi is equal to 20 volt, then diode is on. Diode is on. When diode is on, what is the circuit? Your circuit is, and this is what is, let us say Vi is 20, right? This is what is 20 volt. This is plus, this is minus, right? And what is our V0? Voltage across short circuit. Voltage across short circuit is 0. I am taking ideal diode. You can take it as ideal diode. If it is practical diode, 0.7. But you can take it as 0. Because I am dealing with plus 20, minus 20, you can ignore 0.7. Now, then, what is the second step? Yes, we applied the input for which diode is on. Once you know the diode is on, second step, find the voltage across the capacitor. And V0. V0 we already got it, which is 0. What is voltage across the capacitor? Can I say, when this is short circuit, this capacitor is coming in parallel to your input? This capacitor is coming in parallel to your input. Therefore, your capacitor will be charged immediately with time constant. What is time constant? Time constant is equal to 0. Because what is R? 0. R into C, 0. Within 0 time, your capacitor will be charged. Capacitor will be charged instantaneously. Therefore, this will be, what is voltage across the capacitor? Plus minus 20 volt. This is what is voltage across the capacitor for the first half cycle. Therefore, first 2 points are over. Therefore, first 2 points are associated to first one here for the first phase. Third point is associated to other phase. Okay. Now let's see the second point. The second one is nothing but what? For the other phase of the input. What is other phase of the input? Minus 20. Therefore, when Vi is equal to minus 20. Tell me, is diode on? When I say minus 20, when input is changing from plus 20 to minus 20, when input is changing from plus 20 to minus 20, negative direction, your PN junction diode will be off. When PN junction diode is off, therefore, your diode is off. Your diode will be off. Why diode is off? You may say that there is a capacitor. When input is changing from plus 20 to minus 20, your capacitor is there. Therefore, how can you say that negative is applied to diode? Remember, voltage across the capacitor cannot be changed instantaneously. Yes, we can change instantaneously provided infinite amount of current can be passed. Right? Let us say practically we cannot pass infinite amount of current. Okay. Therefore, now if you see here, when input is changing from plus 20 to minus 20, voltage across the capacitor cannot be changed instantaneously, which has already plus 20 here. Then whatever change you have, 20 to minus 20, that 20 to minus 20, the negative direction will be applied here, because it will be holding whatever it has, and then the change will be applied here. For that change, which is 2 minus 20, your diode will be off. Okay, once diode is off, now the circuit is, therefore your capacitor, which is already charged in the previous cycle, how much that we had seen already, it was charged already to 20 volt. Then diode is off. When diode is off, now resistor will come into picture. Now the significance of R is coming for the negative half cycle. Now diode is off. Then what is your input? Now your input is minus 20. This is minus, this is plus. Right? Therefore now, you may say when I apply minus 20 volt, your capacitor is trying to charge to minus 20. Minus 20 means this will be minus, this will be plus. Therefore plus 20 will become minus 20. But in what time? In 5 times of time constant. But we know that the time constant, this is what you will see, right? We know that the time constant RC is very much greater than the time T by 2 or T. Means in this time, in this half cycle, your capacitor will not charge, it will not discharge. Whatever it has, it will hold it. That's why this is required. If this is not there, then your output shape will be changed. Okay, that's right. Therefore, now tell me what is your output voltage. Now, if you follow KVL, this is nothing but your output voltage. This is what your V0. If you apply KVL, what is KVL? Or I can say this voltage is equal to minus plus minus plus minus 20 minus 20. It will be 40 minus 40. Or you can apply loop KVL. Plus 20 plus V0 is equal to 0. Then V0 is equal to minus 40. Anything is fine. Therefore, if you apply KVL, plus 20, I'm just applying KVL, plus 20 plus V0 is equal to 0. Then what is your V0? Your V0 is equal to minus 40 volt. Okay, this is what is from case 1 and this is what is from case 2. Now let me draw the waveform. Therefore, what is your input? Your input is this is what is your input, plus 20 to minus 20. I think 2 cycles are enough. This is continued. This is the time T. Right? Now we want output. Therefore, this is 20 volt, 0, minus 20 volt. Okay. Now let's see. Tell me when VA is equal to 20, what is your output? Your output is 0. When VA is 20, your output is 0. Okay. This is what we are looking for V0. Then when VA is minus 20, what is your output? Minus 40. Minus 40 is nothing but, this is what is minus 40 you can say. And this is 0 and minus 40. This is what is continued. Therefore, this is what is 0 and this is what is minus 40. Tell me what is your input average signal, that is what is 0. What is your output average signal, that is what is minus 20. Therefore, what happened? The 0 average input signal is clamped to minus 20 volt. Therefore, the signal is shifted down to average of minus 20. Therefore, this is what is negative clamper. This is what is changing the level of your input signal to minus 20. Okay, if I deal with average values. But what it may be, because the square wave it is associated with only 2 levels, but it's the sine wave, just deal with positive peak and the negative peak. What's happening to those 2 peaks? The same thing can be expected for all the input signals, input voltage values what you have. Okay, take it. This is the procedure. This is the same procedure can be applied for different circuits. Wherever you have capacitor, PN junction diode, remember that will do some voltage addition or voltage subtraction. That's what people say. Either voltage doubler, tripler, or 0.5 times of input will be increased. Whatever the voltage will be more than your input. Okay, take it. You take all these 6. Out of all these 6, what we covered? We covered the first one. That is what we had seen, right? And what to be covered? Maybe I'll not cover all 6 because the same procedure to be applied, right? Now, which one to be covered? Second, third, fourth, fifth, sixth. Let me cover fifth one because reverse bias and some positive voltage. Okay. Let's see. Let me apply the same input whatever you have, plus 20 minus 20 square wave. Then let's see what is your output. And VREF you can take some 5 volt value. Okay. And then remaining things you can do homework. See, wherever you have capacitor and then PN junction diode, not only single PN junction diode, you can have multiple PN junction diodes. But wherever you have capacitor, PN junction diode, that will give you a voltage multiplication at the output. Means your voltage value will be more or lesser, whatever may be, than your input. What you call? Let us say your highest voltage at the input is 20. You may say that I am not expecting more than 20. No, from clamper we can expect more than 20 because of the capacitor and then PN junction diode. Okay, we will see those things when we solve the problems. If you follow this procedure for the first cycle itself, positive cycle and the negative cycle, right, you'll get the result. If you don't follow, we need to take multiple cycles, then you'll get steady state output value. Okay, just let us follow this procedure such that for the first cycle itself, we will get the answer. Done? Okay, already the first one is covered. Now let's see what is the fifth one. Okay, these are all typical clamping circuits, but there are many, but I am saying typical clamping circuits. Then already first one is covered. Now let's see the sixth one. Okay, can I arrange? And let me explain the fifth one. Therefore, this is what is the fifth one. Let us take this is 5 volt. This is what your diode D, and let me apply. This is fifth one, right? Let us apply the input. Etc. This is 20 volt. This is minus 20 volt. This is 0. This is what your VI, and this is what is your time period T. Therefore, your RC value is very much greater than time period T. Okay, let's see what is your output. Okay. Now, according to the procedure, apply the input for which diode is on. Tell me for what input, either plus 20 or minus 20, your diode will be on. Actually, this diode is already having plus 5 here. It should be less than 5, right? Or negative value. Then only your diode will be on, right? Case 1. VI, when VI is equal to minus 20, then only your diode is on. We need to apply the input such that your diode is on. When diode is on, then what is your circuit? Your circuit is diode is on, but there is a battery now. This is 5 volt. Now there is a resistor basically, right? But resistor in parallel to a battery. I told already. Resistor in parallel to a battery is nothing but equivalent to battery. That resistor is not having any significance. Okay, that's fine. Now this is what is our V0. Doesn't have any significance in finding your output voltage. Now this is 5 volt. Now this is what is your minus. This is your 20 volt, right? but now this is minus and this is plus, and this is what your capacitor. Therefore, now apply the input for which diode is on. Yes, diode is on. What is the second step? Find the voltage across the capacitor and output voltage. Output voltage is straightforward. What is output voltage? Your V0 is equal to 5 volt. That is done. Now we need to find voltage across the capacitor. Actually, there are two batteries. You can think that there are two batteries. You can apply superposition. Okay. Now, if you short it, superposition theorem. When you short this capacitor is coming in parallel to it. Means this will have minus plus 20. That is because of your input. Now, because of this 5 volt battery, short this. This capacitor is coming in parallel to this. Then it will be plus minus 5 volt. Because of this and because of the reference voltage, all together your voltage across the capacitor is plus minus, both are ideal, plus minus 25 volt. Therefore, this is what is overall. This is nothing but what? Plus minus 25 volt. This is what is voltage across the capacitor. I think second step is also over, and we know output voltage, that is what is 5 volt. Now let's see what the second step, which is nothing but for the other phase of the input. For the other phase of the input. Therefore, what is other phase? When Vi is equal to plus 20 volt. Therefore, what does it mean? When input is changing from minus 20 to plus 20, then it is positive. Then it is positive. Your diode will be off. Therefore, your diode is off. When diode is off, what is your circuit? This is your original circuit. Therefore, now resistor is coming into picture. There is a battery, but it is open, doesn't have any significance. Now this is what is your V0, this is your R, this is C. Now this is what is having plus 20 volt. Okay, but your capacitor is already charged to 25. This is initial condition. Okay, therefore now tell me, and your capacitor cannot charge. Actually, ultimately, under steady state, if you leave like this plus here, minus here, your capacitor will be charged to plus 20, plus minus 20. But resistor, the time constant is very high. In a time of T by 2, for the negative half cycle or positive half cycle, that cannot charge or discharge. Therefore, it will hold like a 25, like a battery. Then tell me, that is what we need. That is the reason why the condition is required. Else your output voltage shape will be changed, not square wave. Charging, discharging will be there. I don't want to see any charging, discharging. I want to preserve the signal at the output. Same square wave. That is the reason why RC is very much important. That should be very high. Therefore, now tell me, what is your V0? Apply KVL. When you apply KVL, minus 20, applying loop KVL, minus 20, minus 25, plus V0 is equal to 0. Then what is your V0? Your V0 is equal to 45 volt. Okay. I think now we got it, right? Now let me plot. Therefore, if I plot, what is your input? Your input is having plus 20 and minus 20. Two cycles are enough. This is plus 20. This is minus 20. Okay, now we want to plot output. Now what is your output? Tell me, when input is 20, what is your output? 45. When input is minus 20, what is your output? 5. Therefore, remember whether you did correct or not. There is a check. The check is, this is now 45 volt and this is 5 volt. What is your input average signal? 0. What is your output average signal? 45 plus 5. 50 by 2, 25. The average value is 25. This is what is the average value. This is your average value. Therefore, what happened? The zero average, which is what is that input, is clamped to 25 volt. The check is your input peak to peak should be equal to output peak to peak. There is no amplification, right? It is passive circuit, right? Sorry, it is passive, but there is no extra energy which you are giving. Even it is having a PN junction here, therefore people say that it is active circuit. Because of that, you are doing some processing. That's why it is active circuit. But remember, there is no extra energy which you are giving through PN junction diode. In the case of BJT, you are giving extra energy through power supply. But here there is no power supply. Therefore, there is no extra energy which you are giving to your output. Your input peak to peak should be equal to your output peak to peak. That is the check. If you are getting output peak to peak which is more than input peak to peak, that is wrong. Or your output peak to peak is lesser than your input peak to peak, again that is wrong. Your output peak to peak should be equal to your input peak to peak. Therefore, what is your output peak to peak? Your output peak to peak is nothing but what? 45 minus 5, that is 40 volt peak to peak. Your input peak to peak is also what? This is what your input peak to peak. That is also 40 volt peak to peak. Okay. I hope everybody understood the procedure. If you blindly follow the procedure, you will get the answer. Okay. Take it. With this I can say clampers are over. I'll give you 1 minute time, then we'll see classroom workbook problems. Okay. Therefore, clampers are over. Then I'll start clippers and GNR regulators. Actually, clippers or GNR regulator, it will take lesser time. See, this is what is the chapter which takes less time. All chapters are lengthy. Chapter 2, chapter 3, chapter 4. BJT amplifiers took so much of time. FET amplifiers also took time. And op amp, that took so much of time because so many topics are converged to chapter 5, chapter 4. Okay. Chapter 5 only diode applications like clampers, clippers and GNR diode regulators. Done? Okay. Now clippers. Remember, clippers also have many circuits, but I'll give you the procedure. You try to follow the procedure, you'll get the answer. Okay. Those are all blind procedures. Clippers. Difference between clippers and clampers. Clampers, it will not change the shape of your input signal. Your input signal shape will be preserved. Only the level or the average value will be changed. But in the case of clipper, the shape of the signal will be changed. Okay. Now, there are many circuits, but I can give you one example. Let us say this is what. Now you can say there are many without capacitor. Okay. Let us say this is all your output voltage. How will you find or how will you know whether it is clipper or clamper? Remember, if there is a clamper means diode, capacitor, they are must. Clipper, just diode and then resistor. That is what is enough. Okay. Or sometimes diode, resistor, capacitor. maybe clipper, but you need to see carefully, okay? But most of the times, I can say 90%, the distinguish between clipper and clamper, diode capacitor clamper, diode resistor clipper, okay? Now this is what is your resistor, and let me tell you the procedure for this is, let us say input is square wave, sine wave, trapezoidal wave, some piecewise linear, whatever it may be. In the case of clamper, I told that whatever may be the type of the signal, just identify positive peak, negative peak, just respond for positive peak, respond for negative peak, automatically what is happening to those peaks, then remaining things will be happening to the other voltages what you have at the input. That's what I told. But here in the case of clipper, don't bother about the type of input. Whether input is sine wave, square wave, trapezoidal waveform, sawtooth waveform, ramp signal, whatever it may be, just don't bother about or don't respond to input. Actually what we do, right, typically what people do when there is a sine wave, what we do when input is increasing, positive cycle diode is on and then negative decreasing, it will be giving you error sometimes. Maybe this is simple circuit, yeah, if you do in that way using common sense or like on and off, you'll get the answer. But there are multiple diodes and input is sine wave, that is very difficult to get the answer. That will give you wrong answer. Further the procedure is, let me tell you, even though your input is sine wave, let us say I am giving a sine wave, which is what is 2 volt and minus 2 volt. This is what is my sine wave, okay, having some period 0 to t, okay. Now don't respond to actual sine wave, not only sine wave, let us say square wave, don't respond to actual square wave. The procedure is, this is simple procedure. Later on I am going to modify this procedure when you see the problems. Number 1, don't respond to actual input. What does it mean? When I say actual input is sine wave, don't respond when input is increasing, what's happening? Treat, or I can say find transfer curve. What do you mean by transfer curve? Transfer curve is nothing but when Vi, input is Vi, output is V0. What is Vi to V0 relation? When Vi is changing from minus infinity to plus infinity, it's a kind of ramp, minus infinity to plus infinity, slow ramp. Then what is your output? Once you know the relation between Vi and V0, once you know the relationship between Vi and V0, okay, then what will happen? Then respond to input, and find V0, This is what is the procedure. But remember, this is straight for don't respond means it is an information. And the second one, find the transfer curve. But how will you find transfer curve? Means what is V0 with respect to Vi? That is what is taking time. That is what is going to take time. Now, how will you do it? The second step involves again multiple steps, sub-steps, right? How will you find transfer curve? Now don't worry about your sine wave, just simply Vi is changing from minus infinity to plus infinity. Then what you need to do? You need to segregate, or you need to have what is called different steps for what input voltage diode is on, for what input voltage diode is off, all those things, okay? Again, to find the status of diode, therefore, again sub-steps, I can say, to find diode status, right? Open the diode. The technique is open the diode. After opening the diode, find voltage across open terminal diodes, across open terminals. Okay. Then Once you know voltage across open terminals, bring back your diode means. You see whether diode is on or not. Then decide diode status. Okay, this is the procedure which you need to follow. This is what is step A. Once you know the diode status, whether it is on or off, see, this is to find diode status for different values of your input. For different values of your input. Once you know the diode status, then what is the next step? This is what is case A, right? This is what is your case A. Now what is your case B? Now case B, actually you need to write because I don't have space. Maybe you can adjust here, case A and then case B. Once you know diode status, it is network analysis. Simply network analysis, KVL or nodal analysis. Network analysis to find V0 with respect to Vi. Simply network analysis to find V0 with respect to Vi. Therefore, if you follow these two steps, you will get the transfer curve between V0 and Vi. Once you know the transfer curve, then the third one is respond to actual input and find V0. You will get the answer. You need to follow this procedure, then you will get it. But remember, even though you are following this procedure, sometimes because you have only one PN junction diode, it is fine. Maybe in some circuits you will have multiple PN junction diodes. Then while solving the problems, I'll explain what is the difficulty and then what to be taken care. Okay, but this is what your typical procedure which you need to follow. Most of the problems you can solve using this procedure, except exceptional problems. Those things when we solve the problem, I'll explain. Okay, take it. I think I can stop this session. We have like 2 to 3 minutes. Try to complete whatever I told here. Then using that procedure, I'll explain what is your V0 for the input signal of +2 to -2 sine wave. Then we will see the classroom workbook problems. Okay, the same procedure will be carried out, right? And there are multiple clipping circuits. By solving them, we will get the answers. Okay, thank you. Please continue.